Hello, my mathematicians. This is Miss Foster with Math in Focus, 4th grade, Chapter 2, Lesson 4, Multiplying Using Models. This lesson is a review of the important division and multiplication work that you did in 3rd grade math. So pay attention. It might be that since you did that work, your brain has let go or loosened some of those important connections it made because maybe you didn't use it over the summer. That's totally typical. But what's fun about reviewing is that once your brain realizes it's supposed to be holding on to something, it will reform those connections and much more easily than it took to build them in the first place. So pay attention to your brain as we go through this lesson and see what your brain is reconnecting today. The first model that we'll be using is an array model, and you can see it down here made with circles on this dot paper. This array model says that there are 4 rows of 15 dots. So to find out how many dots there are altogether, I would want to do 15 times 4. The problem is, I am not really great at doing that off the top of my head. These 2-digit numbers like 15, they can be really hard for my brain to get around. So I can use this model and place value to help me out. You'll notice that they divided this model into 2 colors, blue for the tens and yellow for the single ones. So if I was to describe how many dots were in the blue space, I would say that 10 times 4 will give me these blue dots, and 5 times 4 will give me the yellow dots. Now 10 times 4 is 40. That's a pretty easy math fact for me, and I bet you already have figured out 5 times 4. Yep, that's 20. And I can add these together fairly easily. 40 plus 20 is 60. And so that's how we might use an array model to take a more difficult multiplication problem and break it into easier chunks. Let's try another one. Here we have 17 times 3. There are 3 rows up and down, and 17 in each row. And once again, they've used place value, how I love place value, to help us break this into 2 easier parts. So the blue dots represent 10 times 3, and the yellow dots represent 7 times 3. And once again, I have some math facts that are a little easier for me to deal with. 10 times 3, I remember, is 30. But 7 times 3? I believe that's 21. And notice again, by breaking it into steps, I can easily add these together. 30 plus 21 will be 5 tens for the 3 plus 2, and 1 single 1 for the 0 plus 1. That is the product of 3 times 17. Now, at some point in this lesson or later in the year, they will ask you to make an array model. So I'm going to make one for you up here. I don't usually make my array models with circles. Instead, I make my array models with X's because they're just a little bit easier for me. So what would an array of 2 times 4 look like? Well, I think I would want 2 rows, and then I would want to have 4 of those rows. Is this getting kind of slow? It feels like it's taking forever. You guys, 2 times 4 has a relatively small product of 8, but you saw how much time it took me to make all those X's. That's a less efficient strategy than the next strategy we're going to look at that I really want you to love. So we are here using what's called an area model, where we make a relationship between multiplication and rectangles. Now, if I were to draw a rectangle around this array, you can see it there. But making all those X's takes me a really long time. So in this model, 7 is how many columns go across, and 23 is represented by that vertical edge. But here's a problem that I sometimes have with this stuff. 23 times 7, I don't think the rectangle would really look like this. I think that the rectangle would look something more like this, super long and skinny. And if I actually test that out here, you can see that there should be at least 3 groups of 7 and 23, and it doesn't even have 1. But my friends, these are just models. We need to allow them to just be models. And we're going to draw it in a proportion that helps us to use them well. So we're going to pretend that this length is 23 up and down and this side to side is 7. And you can see that they've divided this into 2 parts, 3 plus 20 on the vertical edge there. And they've broken it into 20 times 7 and 3 times 7. Well, 3 times 7 is 21, but how will we get 20 times 7? Well, 2 times 7 is 14. And this 0 right here tells us, dude, we're multiplying tens. So I just need to get this 0 written in the single ones place because there won't be any single ones. And now I believe that I can add 140 plus 21 fairly easily. 0 plus 1 is 1, 4 plus 2 is 6, and 100 plus no hundreds is 100. So I found by breaking the area model into 2 separate pieces, I can easily find 161 is the product of 23 times 7. So with one more example, let's look at this area model, which is not drawn to scale. It's the area model for 35 times 4. They made the long edge here 35 and the short edge 4. And then you can see that they broke just the long edge up by place value right here. So this blank area represents 30 times 4, and this shaded area represents 5 times 4. We've split 35 into 30 plus 5. Now 30 times 4, 3 times 4 is 12, and I'm going to write that 0 in the single ones place because I was only multiplying those tens. And 5 times 4 is 20, and putting them together, I get 140. Boys and girls, I hope that as we went through this video, the ideas became easier and easier and more familiar for you. These aren't meant to be super hard, but it's really going to help you moving forward into 4th grade math and even middle school math if you understand how to be flexible with your numbers, breaking them into easier chunks, and also to understand that multiplication and division problems are modeled with different kinds of rectangles. Hey, thanks for playing with modeling multiplication with me. I love area models so much. It's been so much fun. Bye-bye for now.